Hello students, my name is Sumit Sagar Hota. I am a PMRA PG student at IIT Palakkad. Today we will discuss lecture 4 of the subject Introduction to Airbreathing and Propulsion by Professor Ashok Desai, IIT Kanpur. This is the lecture 16 to lecture 20, and this is the week 4 of the live discussion section. In this section we will solve some of the MCQs as well as some of the problems. Okay, so just quickly start the section. So which of the following is correct? So static speed, so this obviously the formula is pi nd by 60 feet per second, or whatever the your SI units if you can do. Okay. So n is the RPM and d is the diameter of the propeller. And this is just static speed. Okay. So next is the helical tip speed is given by which formula? Okay. Helical tip speed is always a resultant. Okay. So that will be option A. Between the tip speed and the actual speed of the aircraft. Okay. So the tip speed, what is the requirement of finding a tip speed of the helical tip speed? So tip of propeller is following a helical path through air. Okay. Okay. So the next question. The propeller has a diameter of 25 unit. What will be the static tip speed of the propeller? Okay. So here the things given are d is equal to 25 unit, n 1200 rpm, So let's go to the solution. So v is equal to pi n d by 60. Now we just seen this formula. Okay, so 5 into 1200 into 25 divided by 60. So the answer will be 1570 point unit RPM. Okay, so the answer is A. So A is the answer. Okay. So if a propeller is designed to have a 200 horsepower and then find appropriate diameter for the propeller, consider two blades. Okay. So we need a 200 horsepower, number of blades is equal to 2. Let's go for the solution. So the formula for the two blades is two blade propeller is 22 into horsepower to the power 0.25. Okay, so 22 into 200 to the power 0.25, 82.73 unit. Okay, so answer is A. Okay. Let's consider we need to design a propeller engine which has 3 blades. What will be the typical value of the propeller diameter? Engine is expected to produce a 400 horsepower of power. Okay, so also there is a formula for 3 blades also. So first we see what are the things given. P 400 horsepower, number of blades 3. Okay, so D for 3 blades, (18) into horsepower to the power 0.25. Okay, 18 into 400 to the power 0.25. (80.5 unit. Okay, so answer is A. Which among the following casting process is used in the casting of the piston? Okay, answer is D, which is gravity die casting. Okay, it is used for both casting and forging. Okay, so which of the following is the main reason for a burnt piston? Okay, actually here the question is little tricky because some of the terms you may not know. That's the reason this question is tricky. But in place of this D option, which is detonation, if there is an option called pre-ignition, then it's very easy to answer this question. So detonation is otherwise known as pre-ignition. Okay, and it is the point farthest from the spark plug where the hot end gas rapidly release their energy, and this is the main reason why there is a burnt piston. Okay. Okay, so let's go to the next one. Which material is coated on the piston to increase the service life? Okay, this is a very good question. It's very commonly used coating is tin coating. Okay. Now why it's coated, that's the real question. So increases the service life, which in turn means reduces the possibility of scoring, which in turn damages the piston. So and also this is a prevents from oxidizing, okay, and any kind of corrosion, all these things it will help. So antioxidant and tarnish resistance. Okay. So what is a piston? Piston is a dash part of IC engine. Okay, piston is always a reciprocating part. Okay, because it cannot obviously rotate or revolve. Okay, oscillate also I think not possible. Okay, so obviously we will always take at a reciprocating part. Okay. Okay, next question. Why the length of the piston in the two-stroke engine is more than compared to the four-stroke engine? Okay. So basically the answer is A. There is no valve mechanism in the two-stroke engine. Okay. So So that's the reason why the intake and the exhaust of the two-stroke engine have to be controlled by what? The piston itself. Okay, that's the reason why the length of the piston in two-stroke engine is more as compared to a four-stroke engine. Okay. What is the convex part of the piston on two-stroke engine is known as? So what is that it will do? It will deflect the gas. Okay, so that's the reason its name is deflector. Okay, because always the convex portion always deflect any kind of ray or any kind of fluid. Okay, so kind of that way you can know it. Okay, so okay, so what is the real work of deflector? One more question they can ask. So it helps in scavenging and diverts the exhaust gases to move towards the exhaust port. Okay, this is the importance of deflector. So which component of the piston and the connecting rod are connected? It's obviously connected through a pin. Okay, so piston is there and one connecting rod is there. Okay, so two cylindrical components can be joined obviously through a pin. Okay, so that's the reason why this the name of the pin is Gudgion pin. Okay, so the piston and connecting rod is connected through Gudgion pin. Okay, so which part of the piston experience high thermal stress? Okay, basically the head will experience the high thermal stress. Okay, because their intake and exhaust, all these gases will directly come in and go out. Okay. Or we can tell the head as what? Piston crown. Okay, when is the choke used in the engine? So basically when the engine is cold, in the cold edge, in the scooty, if you really going to see it, there actually we have a choke. Okay, we just pull that lever and wait for 3-4 minutes. Okay, so that the fuel flow will be very frequent. Okay, and then we just put it in the original position, and so that the whatever the fuel is there, it will go very easily to the engine. And it's basically choke is a butterfly valve located between the entrance to the carburetor and the venturi throat, so which allows the frequent flow of the fuel to the engine, and that's the reason why in the cold days it's easier to charge these engines. Okay, but these things also available in bikes also. There we have to actually turn one pin. Okay, just near the just below the tank, oil tank. Okay, so butterfly valve means uh, So this is the maybe one valve's inlet. Okay, one cross section of the inlet and pipe or whatever I can now showing. Okay, so butterfly valve is a valve. If it is open, okay, and inside it one disc will be there. Okay, if it is closed, this whatever the disc inside will be closed. Okay, and if it is open means it will be open. Okay, means it can rotate like this. I can show it. Okay, so okay, so when it's closed, there is no flow can go inside the inside this whatever the pipe or this, especially the fuel. Okay, there is no fuel can go inside. Okay, through this gap. Okay, and when it is open, okay, there is a, it just rotates and somewhat anti-clockwise or clockwise, and it's become open. The fuel can go inside through these gaps. Okay, so it can actually connect it through this, and it can actually rotate. Okay, so this is actually a okay. Okay, so this is a butterfly valve. So what I will do, the choke is a butterfly valve. Okay, so where it's located, located between entrance to the carburetor and venturi throat. Okay, so this is where the position of your what, okay, carburetor. So next is, what does this venturi in the carburetor cause? Okay. So the venturi in the carburetor always increases the what, air velocity. Okay, because what is a venturi is a convergent divergent kind of case. Okay, so in turn, what is the work of carburetor? Carburetor always keeps some reserve fuel at a constant head. Okay, and the venturi in the carburetor increases the air velocity. Okay, that means because of this carburetor and venturi, there will be a very good mixing of the fuel and oxidizer, and it will, which the engine will work very properly. Okay, so that's sort of the idea of carburetor. So where is the lean air fuel mixture is needed? Okay, the lean air fuel mixture means where the weight will be the very much concern, and those cases there will be it is needed. Okay, and also here the speed is nearly constant everywhere, and there is not requirement any kind of higher fuel amount to increase or decrease the velocity, higher or lower amount of fuel. So in those cases there will be lean air fuel mixture is needed, and the best option will be what? Cruising. Okay, it should be noted that it's not idling. Okay, idling means you're not doing nothing. Okay, so there is no fuel required. Okay, but in cruising you need some fuel, so lean air fuel mixture is needed. Okay, that's the reason why if you also see in the cars, when there is a cruise controls are nowadays given in the cars, so that it will be fuel economy in those national means highways, all these areas, as compared to the town or traffic areas. Okay, also the carburetor provides the engine the best fuel economy that we see previously. Which of the following is the lean air fuel mixture needed? Done. Next question will be just okay. So which of the following is the most accurate petrol injection system? Okay, okay, so always there is a in petrol engines there will be some small ports are there. Okay, or small you can tell it as a sprays. Okay, injector sprays are there, and through which the there will be a what, the fuel will intake to the intake port. Okay, okay, in the inlet valve. Okay, so there is a injector sprays, and injector sprays are there in what, through what, port injection, and this is the most accurate petrol injection system. Okay, so injector sprays the fuel into each intake port in the manifold side of the inlet valve, and this is the most accurate petrol injection system. Okay, is the port injection system. So let's go to some small problem. What is the value of the rate of flow of fuel if the coefficient of discharge of fuel is 0.75, area of the jet is 0.885 mm square, the density of the fuel is 780 kg per meter cube, and the pressure differential causing the fuel flow is 15,000 pascal. Okay. So let's write down what are the things given. The rate of flow of fuel. Okay, so this is the formula, just we have to substitute the values and we'll just get the answer. Okay. So the nearby the option will be somewhat 3.21. Okay, this may be due to this they didn't consider some of the decimal places. That's maybe the reason why they are not getting the options. The options are actually basically little bit wrong. The answer will be this 3.1, but yeah, whatever the nearby options, always you choose. Okay. Okay. The thermal efficiency of the petrol and gas engine is about what? Okay. Petrol engine having very least efficiency as compared to your what? Diesel engine. And efficiency of the diesel engine, this is 70%. Okay, it is assumed that all the processes of an air standard cycles are what assumed means obviously you see the what are the most common assumptions. Okay, and they are telling all the processes always processes means processes cannot be a single one quantity like adiabatic or isothermal. Okay, processes means something going on. Okay, from the starting to the end or from the inlet to the outlet. Okay, so obviously let's say what irreversible or reversible, obviously say reversible one. Okay, reversible. Okay. The thermal efficiency of the standard Otto cycle for a compression ratio of 5.5 will be what? So what is the formula of efficiency of Otto cycle? 1 minus 1 by r to the power gamma of air minus 1. Okay, and we know what is the gamma of air, 1.4. Okay, ratio of specific heats, r is your what compression ratio. So 1 minus 1 by 5.5 to the power 0.4. Okay, you calculate it, is comes out to be somewhat 0.4943, and if you convert it into percentage it will be 49.43 percentage, which is near to your 50 percentage. So answer is B. Okay. The efficiency of the Otto cycle increases by increasing what? Okay, so first write down the formula of efficiency of Otto cycle. 1 minus 1 by r to the power gamma minus 1. Okay, so we have to increase something. Okay, there is only one there is two quantities, one is gamma and r. Okay, but in the options if you see there is no gamma concept is there. So if you don't want to do anything, directly choose the answer compression ratio, no need to think anything. Okay, but still I will show you the procedure. So if the r will increase, okay, the r will increase means is 1 by something will increase. That means this whatever the term it will be there, this will what? This will decrease, or more specifically it is less than 1. Okay, so if it is less than 1, 1 minus less than 1 will be what? 1 minus less than 1 will be positive quantity, or it will what? If it is very less than 1, that means this value whole quantity whatever it's there, this is going to what? This whole quantity will what? Going to increase. Okay, but yes, if it will increase, but this will be what? Also less than 1. Okay, that means this whole quantity will increase it, which in turn increases the efficiency of the what? Otto cycle. Okay, so that means your by increasing r, your what is the compression ratio, the Otto cycle efficiency will increases. This is a question of if you know the cycle, Otto cycle, then only you can answer this question. Okay. So this is the schematic of a auto cycle. Okay, so just let's write down what are the things. So it's actually answer you can write down. This is as what see, this is your auto cycle. So there is a, if you see 1 to 2, the S means entropy is constant, which is isentropic, and here in 1 to 2 WC means compressor, so there is a isentropic compression. Then 3 to 4 is the turbine is there is a also what, if turbine means expansion, that means also here entropy is constant, which is expansion, isentropic expansion. Then if you can see 2 to 3 and 1 to 4, 2 to 3 heat addition, and 2 to 3 1 to 4 is what, sorry, 4 to 1 is your what, heat rejection. So and it is done in what, constant volume. Okay, this is basically your auto cycle. The answer is obviously C, which contains 2 constant volume processes and 2 constant entropy processes. Okay. So the constant volume cycle is also called what, obviously I now only shown say auto cycle. A diesel engine has compression ratio from dash to dash. It's actually this is a remembering kind of question. Just remember it as 16 to 20. Okay. So in diesel cycle the heat addition takes place at what they are asking. Okay, so there is a small difference between the diesel and the auto cycle, as the heat addition and heat rejection are done at what, constant pressure. Okay, and just directly take that one. Here the pressure is constant, and this is your what? This is your diesel cycle. Okay. The answer is what? B. Yeah. So what is the combustion in a SI engine, spark ignition engine? So combustion in SI engine always homogeneous, and in a compression ignition engine, that is CI engine, it's always a heterogeneous combustion. Okay. Because in SI better air fuel mixing. Okay, and here high amount of fuel, maybe due to which there is a heterogeneous combustions are there. So next the question. Okay, a four cylinder 4-stroke petrol engine has a 10 centimeter bore, 15 centimeter stroke, and use a compression ratio of 6. The engine develops a 25 kilowatt of indicated power at what? 2000 rpm. Then find the mean indicated pressure and the air standard efficiency. Also calculate the fuel consumption per hour. If the indicated thermal efficiency is 30%, then take the calorific value also 42 megajoule per kg. So let's solve it. So what are the things given? The 4-cylinder So what we need to find? Air standard efficiency of the Otto cycle, okay. Then what? Indicated thermal efficiency also. Not indicated thermal efficiency, indicated mean pressure, okay. So let it be PMI, indicated mean pressure, mean effective pressure. Then the third will be your fuel consumption per hour, m dot f. M dot f in kg per hour. Okay. So next, what are the assumptions we can take? We are assuming the petrol engine works on the air standard Otto cycle, because in practical it's not possible, okay, because there is some losses involved. And gamma we are taking for a AR 1.4, okay. So let's go to the solution. One minus 1 by r to the power gamma minus 1, 1 minus 1 by 6 to the power 0.4, which is 0.511 equal to 51.1 percentage, okay. Next year, okay. So first we need the indicated mean effective pressure. First we'll take the indicated power first, okay. So what is the formula for indicated power? IP is equal to indicated mean effective pressure into LANK divided by 60, okay. Substitute the values. 25 10 to the power 3. PMI we need to find out, into LE 0.15 given, cross sectional area of the piston cylinder, whatever the arrangement is there, okay. Bore strokes, all these things are given, okay. From there we can calculate. Pi by 4, 0.1 square into n is your 1000 into how many cylinders? 4 strokes and 4 cylinder engine, so K equal to what? 4, okay. So this 4 stroke means K equal to 4, so 6 cylinder engine, okay. R is equal to 6, that will come, okay. So 4 strokes, so K equal to 4, okay, divided by 60. If you solve it, you will get the PMI as 318.3 kilopascal, which is equal to 3.183 bar. Okay. Next we find out the fuel consumption per hour. So for that we need the the efficiency. Okay. Indicated power divided by m dot f into calorific value. Okay. So 25 kilowatt divided by so what we do, just do some little rearrangement. M dot f is equal to indicated power divided by efficiency into CV. 25 divided by 0.3 into 42 into 10 to the power 3 kilojoule per kg. This is kilojoule. Kilowatt, 25 kilowatt. This is your kilojoule per kg. Okay, so the unit will be what? In kg per second. Okay, because this will be what? Your kilojoule per second. So kilojoule get cancelled. The final unit will be what? Kg per second. Okay, so 1.984 10 to the power minus 3 kg per second. Now just what? Second, 1 second 3600 hour. Okay, just multiply 3600 with this above term, 1.984 into 10 to the power minus 3. You'll get it as 7.14 kg per hour. Okay, this is your answer. This is your answer. Okay. So next question. This is a little big question. Okay, the question is a single cylinder 4-stroke diesel engine works on the following data. The cylinder bore 15 cm, stroke 25 cm, speed 25 to 50 rpm, area of the indicator diagram 6 cm square, the length of the indicator diagram 9 cm, spring constant some 7.5 bar per centimeter, brake specific fuel consumption BSSC 0.24 kg per kilowatt hour. The calorific value is 42,000 kilojoule per kg. Diameter of the brake wheel is 70 cm. Rope diameter 3.5 cm. Brake load 40 kg, which is a 392.4 Newton. We need to calculate the brake power, indicated mean effective pressure, indicated power, mechanical efficiency, indicated thermal efficiency. This question covers most of your whatever the question they will ask as a short question, 1 mark, whatever in the MCQs. It's only one question, it will be enough. Okay. We will write down what are the things given. Okay, let's do it. K equal to 1 because it's a single cylinder. Okay. Okay. So what we need to find? Okay. So before calculating all these 5 terms, we'll just calculate some of the basic terms, then we'll go for the these 5 ones. Okay. So what is the effective brake radius? What is the torque? So this is your torque. So let's calculate now. The brake power in kilowatt 2 pi nt by 60, since converted into kilowatt, divided by 1000. Torque we calculated now, divided by 60,000. Okay, which gives the value 3.775 kilowatt. Next will be your indicated mean effective pressure. A by L into C. Okay, it's all there in centimeter. Okay, so because centimeter square and centimeter. Okay, so this is actually get cancelled. Okay, and C also in unit is in also centimeter. If you really going to see it, it's 7.5 bar per centimeter. Okay, the unit of C 7.5 bar per centimeter. L and AI are also in what? Centimeter square and centimeter. So centimeter and centimeter square. So that's the reason why you can write down it as what? 7.5, which gives to BF in units of watt bar, which is 5 bar, converted into kilopascal, which is 500 kilopascal. Okay, so third one, the indicated power. So indicated power IP equal to indicated pressure into LNK divided by 60, because it's already in kilopascal, no need to divide it by again 1000. Okay, so 500 kilopascal, put it here, but so this is your 500 into 0.25 into a is your pi by 4 d square 0.15 square, n is your 250 by 2. What is the number of cylinders? Is 1 divided by 60. We will do this, will comes out to be somewhat 4.6 kilowatt. Okay. Then next comes the mechanical efficiency. Which is the brake power divided by indicated power. 3.775 divided by 4.6 comes out to be 0.82 or 82% efficiency. Okay, so next will be your indicated thermal efficiency. Okay, so for that there is one relation between, we need to find out the m dot f. So for m dot f we need the brake specific fuel consumption, BSFC is equal to m dot f by brake power. So we need m dot f, which is brake specific fuel consumption into brake power, which is 0.25 into 3.775, so comes out to be 2.516 10 to the power minus 4 kg per second. Okay, so now just we can calculate the indicated thermal efficiency, which is indicated power m dot f into what, CV, calorific value. Okay, so which is equal to 4.6 divided by 2.516 10 to the power minus 4 into 42,000. Okay, 0.435, 43.5%. Okay, so this is what the answer. Okay, so thank you very much. We can into this one. Okay, thank you very much for attending the section. If you have any doubts, you can ask in my YouTube channel. My name is Sumit, my channel name is Sumit Sagar Hota. In comment section you can ask any doubts. If you have any other doubts regarding the lectures, you can ask in question and answer forum in NPTEL. Thank you very much for attending the section. We can see the next week section in the next live section from 6 to 8, Saturday 6 to 8. Okay, thank you very much and good night. Have a nice day.